Oh,
Chris,
hang on.
Chris, welcome to the. Are you there?
Sorry, hang on. I got an error message on the camera. I think it resolved itself. You want to just start
That's all
again?
right.
Sorry if that screwed things. Yeah.
No, don't worry, the origin. Chris, welcome to the Astrophysics podcast. How are you?
I'm all right, thank you. It's cold and clear here in Oxford, so looking forward to some stargazing later.
Absolutely. It was only a little bit warmer down here in London, but yeah. So I guess the weather in the UK is very much a factor when you're looking at the stars, right? How are you always on AccuWeather? How do you know when it's okay to go out, or is it sort of?
Well, I'm a great believer in terms of going out myself and looking up. I'm a great believer in what I would call lazy astronomy. So, whereas lots of amateur astronomers who I meet around the country and around the world do amazing astrophotography, have these big projects to take deep sky images or to monitor the weather on Jupiter. I just like looking at things. So I don't bother with weather forecasts. I've learned over the years you can never really predict what's going to happen. So if it's clear, I'll go out and look up. Or often these days, if I'm going to take my dog for a walk in a bit, so we will share the sky later. I was going to plug this later, but he and I have our own podcast called Dogstars, in which I talk to him what to see in the night sky, and he tries to eat pizza that's been left on the street. So, yeah, I mean, at the minute, if you're an astronomer, Jupiter's beautifully placed, and I like seeing sort of just how the sky changes from week to week and month to month and year to year. The constellation of Orion is beautiful at the minute. And I suddenly got this sense of, my God, it's January, because Orion's right now at sunset. We started this new year. And I remember seeing that over the last few years as well. So I do think you get the sense, even from just looking up, of time passing and sort of the cosmos being right there.
Yeah. Well, I say at the end of every episode, I say, look up at the stars, not down at your phones. I'm always trying to encourage people to kind of look up, because you do forget, even looking at the moon is sort of awe-inspiring, and you get that cosmic perspective that actually, what's going on in your day-to-day life, doesn't really matter in the grand scale of things. So there's definitely a humbling experience with looking up.
Yeah, I think that's right. And even in the city, as you say, you're in London, even being in the city and knowing that the bright star is Jupiter, or seeing how the phase of the moon change, you do get this sort of connection. We talk a lot, I think. I meet a lot of people who say they have seeing a dark night sky on their bucket list, something to do one day. And I think, well, yes, seeing a dark night sky is amazing. Some of the most memorable moments of my life have been out under very dark skies in places like Chile or New Zealand, or Exmoor occasionally, closer to home. But you don't need to do that to connect to the cosmos, to get this sense. And there's always this thing of, I think one of the things we get from looking at the universe is a sense of feeling very small on our planet. If you look at the Hubble Deep Field and you see thousands of galaxies, or you realise that every star in the sky probably has planets going around it. But there's this sense of familiarity as well, this sense of being part of that cosmos. So, yes, all these stars have planets around them, but the Earth's just a planet. And yes, there are all these galaxies, but what we're seeing is the story that led to our Milky Way being here. So, actually, I opened the new book that I've got out this year, Accidental Universe in the UK, or Accidental Astronomy in the US, and opens with the discussion of this sort of sense of awe and wonder, these two feelings, this sense of being lost in this vast cosmos, which can be quite scary, and the sense of being at home in it and finding a connection to it as well.
Sure. I'd love to talk about your book, but I think there is definitely a constant. I find it reassuring, looking up at especially the moon. I don't know. I have a close connection with the moon, and you think about how it's been the same moon. The Romans looked at it, the Egyptians looked at it, and it basically hasn't changed at all. It's kind of it's that constant in a world that just changes, and I think it's quite. I think more people need to have that cosmic perspective. It's something I'm definitely very passionate about.
I think that's right. And I think the nice thing about the moon is that it has those two things. Again, it's always been, as you say, it's receding from us at the rate that your fingernails grow. That's not very fast. But it's also, I don't think you ever see the moon in exactly the same way twice. So every phase is different. There's this well-known thing, which I'm sure you know about, called the moon illusion, where when the moon is low down on the appears much larger than it really is in the sky. This is incidentally why if you see a beautiful moon that's just rising, you try and take a picture with your mobile phone. It's always disappointing.
Yeah.
Because your phone doesn't see the illusion for some reason. And so the fact that it changes the sky also wobbles. If you pay a bit more attention, of course, as it goes around the Earth, it wobbles. We see around the edge occasionally. The phases will make craters look different. Things like, what are they, Plato and Copernicus, these big craters with rays stand out at full moon, whereas you don't hardly see them on different phases. And so it does reward looking, and that thing of whenever you're outside, you step outside in the evening and it's dark, just look up and pay attention to what's going on, and then you get the sense of being connected to where the moon is in its orbit, where the Earth is in its orbit, and what the sun is up to as well.
I think astronomy has become a lot more accessible as well, because I bought a telescope in 2020. It was a pretty decent-ish one that I could find on Amazon. I had no idea how to use the bloody thing, but then you go on YouTube and there's all these videos, real basics like, make sure it's level, how to make your telescope level, how to align with true north. And there's so much YouTube, especially, and other platforms. They do make it easy. So if you are in a position to get a little telescope, it makes. I remember when I looked at Jupiter for the first time, it was like, oh my God, that's actually Jupiter.
Yeah.
Like, that's insane. And you can count, I can't remember, I think you can see about 5 of them, right? Something like that.
Of the moons, at least in a small telescope. If you know, the trouble is you have to know where they are. But even in a small telescope, you can get up to 10 or so. They're pretty bright. But you have to know they sort of look like background stars, and all you need are a very, very, very clear sky and good conditions. But you're right, a small telescope show you Jupiter, Saturn, obviously spending a lot of time looking at the moon, star clusters in the Milky Way as well. And I think, again, for me, it's about simplicity. So I'm still using, again, I'm not an astrophotographer, but I'm still using the 6-inch reflector that I bought when I was a school kid. Paid for by selling ice creams on Torquay Seafront rather badly. I saved up all summer for this telescope, and it doesn't have a drive, and it's a pretty basic thing. But it has the advantage that my setup for it involves taking out the shed and plonking it on the ground. And the phrase is that the best telescope is one you'll actually use. And so
that's good point.
When people ask, I always say, get something that you can use. So if you've got space for a setup that's permanent, then great, you can get into that stuff. But if it's going to live in the kitchen and be taken out when it's clear, you want something that you could just plonk down and use rather than set up. So it becomes habit forming. I think astronomy is best enjoyed as something that you do often rather than once in a year hobby. Because, as I say, the sky and the universe is always changing.
Have you always been fascinated by the cosmos? Do you remember looking up for the first time and starting thinking those questions? Do you remember when that was?
Yeah, pretty much as far back as I can remember. There were a couple of early moments. So Halley's Comet, which is now at its furthest from the sun, swung through the inner solar system in 1986, and I was 5 or 6, and I remember being taken outside by my parents to try and see it. Now, we had no idea what we were doing. We had no telescope or binoculars. Halley's Comet wasn't very bright. I'm pretty sure we didn't see it, but I remember trying to see it. And then somebody took me to an observatory when I was 8 or 9, and we saw what's still one of my favourite objects, which is Albino, which is a star at the bottom of the cross of Cygnus, which to the naked eye looks like a normal star. But if you look with any kind of optical aid, it's a double star, and they're contrasting colours. So I see them as blue and yellow, but colour is really subjective. You can find people describing them as anything from purple and green and something. They're coloured stars. And I remember seeing them through a telescope, and it was the first time I got, if you look through a telescope, you see this, if you look with the naked eye, it looks different. And that was exciting. I think mostly what I was excited about was that the telescope was out of focus, and so they looked not like points, but big balls, and I thought I was seeing the actual stars. So, I learned more later. But it was really that looking through the eyepiece, and I very quickly got into learning constellations, doing things like meteor counting, so sitting out in a deck chair with a tape recorder, trying to record the Perseid meteor shower or the Geminids in the middle of December. And it's been part of my life ever since, really.
talking about seeing different colors on through a telescope or looking at the stars. This week I read that Uranus and Neptune are actually the same color, and I found that pretty devastating. I don't know. What's your why did astronomers get that? Well, not got it wrong, but is it just that new technology has actually been able to see them, or why did we not know that they were basically the same color?
Well, it's an interesting story. So this was work actually by Pat Owen and my colleagues in Oxford. This. And it's old data, right? So these aren't new observations. So it's not that somebody's got a new camera or a spacecraft and looked at Uranus and Neptune and gone, my God, they're the same. What they did was went back to the original Voyager data, which is still, Voyager 2 is still the only probe that's been through these systems. And they did a very careful job of calibrating the images and then processing them such that you get what we might call true color, but the kind of color that we'd see. And it looks very different from the traditional press images. So every textbook has the same two images. It has Uranus as this nice pale blue world, and then this dark blue Neptune with the great dark spot on it. When people have made choices about how to show things, they've matched those palettes. But those aren't true color images. So this was known at the time. So Daniel, I'm not going to remember his name, but there's a German amateur general watcher of things astronomical who pointed out online that if you go and watch the Voyager 2 press conference, they show a true colour Neptune and it's much like Uranus. And then they exaggerate it to show the features in the atmosphere and you get this dark blue one. So this is sort of known. But the thing that's really interesting, and I was talking to my friend Will Gator, who's an expert at observer and astrophotography about this, and both of us have had experiences of looking at Neptune and Uranus through a telescope. And both of us have convinced ourselves that Neptune is a darker colour than Uranus. Now, according to this research, that can't be the case. But I'm pretty sure that's because my brain was expecting a darker version of Neptune, right? Because that's what I've seen in every image. So I'm intrigued. I really haven't done this yet, but I've got to get the scope out, go and look at Neptune and see again what's there. But it did make me think about one thing. So that there are lots of observations of, well, at least a handful of observations of Neptune from long before it was discovered. So famously, Galileo sees Neptune. There's a sketch in one of his notebooks that shows Neptune, but he doesn't recognize that it's a planet. He's got a telescope that's too small to show that it's a disk, really, which is the distinguishing feature. But I've always wondered, he must have seen that it was this dark blue colour, but maybe if the colour's not as obvious as as we thought, maybe that's an explanation. Possibly he wasn't looking for a slow-moving planet in the outer solar system. But yeah, it's a fun result. I love that it sort of confused people, but certainly it's good to have the new processing image. That was the point, really, to better understand the atmosphere by doing the processing more carefully, given what we now know about how to handle this data. It has created this sideline of I think, people thinking that we've sent a new probe suddenly. There's a similar thing if you look at successive missions doing imaging on Mars, like the Vikings in the 1970s, and then into the Pathfinder and the Spirit and Opportunity era. The colour of the sky changes from mission to mission because they have different opinions about how to calibrate it. And there was a period where, certainly from the Viking images, people thought Mars had this like pink glow in the sky, and actually it's pretty Earth-like. It's a bit different, but now we've got proper calibrations and colour cameras there. We can do a better job of this. So yeah, colour in astronomy is always tricky.
It's such an important part of astronomy, isn't it? It's like our very sort of limited human looking out and trying to explain things, like how things look is a huge part of that. Well, I'd love to, talking about, the sort of discoveries and accidents and things. Your book, your new book. Tell me about that, because I'm intrigued. Why the focus on sort of accidents and discoveries is where did the sort of captivation of that sort of concept come from?
Yeah, so the idea is to tell stories about where astronomers have been surprised and stumbled on truth. And there are a few triggers for that, really. One is, I think it's very easy to get the impression that we know what we're doing. So, I think you don't have to read many books on physics or on science to came across the idea that science happens when we have a hypothesis and then we design an experiment to test it, and then you get an answer that's yes, or you get an answer that's no, and then you go and think harder about that. And that, there are fields where that happens, and that does occasionally happen. But it's not the experience of being a professional astronomer at all. We are people who build observatories, not experiments, right? So we build we think about new ways of exploring the cosmos, and then we see what we find, and then we try and develop theory to understand it. So I wanted to get away from this sense that science was proceeding in sort of regular order of test after test of theory after theory. Most encapsulated by a quote from my friend Meg Urey, who's the person who worked out how black holes power galaxies. And in her opinion, there's no major discovery in astronomy in the 20th century was made deliberately. Couple of cliches. So, the stories in the book range from well-known ones, like the discovery of the microwave background, which was made by a couple of engineers who were looking for sources of radio interference and found this first light in the universe that tells us about the early universe, to more recent surprises like phosphine on Venus, which is a potential biosignature, so maybe a sign of life, which was made by my friend Jane Greaves when she was trying to just show off what a telescope can do, with no thought really that they'd actually find anything. And Oumuamua, which flew through the solar system unexpectedly, this instant orbit. And then we managed to dig back to some history, which is really interesting. So we talked about the early days of radio astronomy, where the whole concept of radio astronomy was driven by Jansky and Reber, who were a couple of outsiders. They were radio engineers, but they weren't astronomers, and astronomy as a whole wasn't ready for these great pioneers to come in. And if you're an astronomer at Harvard in the early 20th century, and you get a letter from somebody who lives outside Chicago, who's got a telescope they've built themselves that looks nothing like a telescope, and they're telling you they know what the structure of the galaxy is. These people were not only surprised but pretty cynical about it. So there is there's also this long history of amateur involvement as well.
Yeah, and your book emphasizes the importance of keeping an open mind in astronomy. Do you think that do you think that mindset has personally influenced your approach to research and exploration?
I think so, and I think it links to what we started off talking about as well, which is the joy of looking at the night sky. I think, I'm an astronomer who started as a kid looking at the sky and wanting to be surprised by it. I remember, I was very obsessed for a while that I wanted to discover my own comet. I still think Comet Lintott sounds great, but I think you need more than a 6-inch telescope, sadly, these days. But you can do it online. There are projects that we run where people can try and find comets. But so I think it was this. I come from a background of being an observer, of wanting to look, and I think many of my colleagues come from theoretical physics or mathematics and have maybe a slightly different approach. A good example is I'm involved in a very big collaboration that's building an amazing instrument that you're all going to hear a lot more about, called the Vera-Rubin Observatory. And Rubin is going to do a survey of the whole sky. So it's an 8-meter telescope. It's as big as the biggest telescopes in the world today, but it's going to scan the whole sky every 3 nights. Wow. 30 terabytes of image data a night. We built a system that will send alerts whenever anything moves or changes. So we think, don't know, no one's done this before with this sort of telescope, but maybe 10 million alerts a night if we're lucky, maybe 20 million if we're not. And everyone else, not almost everyone else in the project, is worried about how to find more of the things that we know exist. And this is where I close the book. I'm interested in finding the unusual stuff. We're looking at the sky in a new way. There will be new things there. And so how do you build a system that allows you to be surprised by the universe when you get 20 million text messages a night saying that things have changed? That's notifications. My current research as well.
That's notifications you want to turn off.
That's right. Well, and like all good notification systems, you want to filter. But how we filter, the trouble is, the challenge is this: that most unusual things are boring. Right, so most unusual things are going to be the camera malfunctioned, or one of Elon Musk's satellites got in the way, or that's going to happen a lot, or there's a bright diffraction spike from a star that's nearby. But buried in there will be new types of objects and new things behaving in new ways. So So the challenge in the book is to remind people that we need to look for those things as well.
Which makes sense. The universe works in mysterious ways, and if we're just looking for radio signals, like some sort of ET that's going to have like a transmitter,
right,
we got to think completely differently. Well,
and actually, sorry, no, after you. Sorry,
no,
Don,
you
I
go.
was going
You
to
go.
talk
Tell
about
me.
SETI. Well, I was going to just say, because you mentioned like SETI, and I opened the book with SETI, and we're getting more involved here in Oxford as well. The Breakthrough Listen project, which is this huge search for extraterrestrial life, is now based here. And so, talking to them, it's interesting. SETI is changing. So for years, it's been about searching for us in the cosmos. So we're assuming that we're looking for radio transmitting civilizations. We're assuming that we're looking for signals that we would find hard to send, narrow band signals at particular frequencies. And that there's much more. I'm finding, talking to the SETI community, getting more involved in that world, there's a much broader sense of what we should look for now. So, conversations about everything from optical SETI, where you're looking for laser pulses amongst the stars, to maybe even, stuff on a galactic scale. Would it be important to, or would it please some advanced civilization to make stars flash together on opposite sides of the galaxy? Would we find that if it was happening? And this sort of broad-minded search for the unusual is becoming a core part of how we think about SETI as well.
And what do you think? What do you think is out there? I mean, I'm asking you to, the big question, obviously. But what's your hunch? Not necessarily just ETs, but what big discoveries do you think we're going to see in the next decade when it comes to looking at the stars?
This is very much like my funding proposals. Whenever I ask for money to employ people to do this stuff, I get this sounds great, but given that you're searching for the unusual and unexpected, what is it that you're going to find? But I can give you some examples, I think, of what might be out there. I think one of the most exciting things that we're seeing is the results from gravitational wave observatories, where we're seeing ripples in space-time caused by things like colliding black holes. At a minute, we've found events that we can explain. They're teaching us that this sort of massive collision of objects happens a lot in the cosmos, and some of those will be visible in the optical. So I think we'll find new types of optical transits, maybe very fast supernovae, or perhaps the opposite, perhaps supernovae that appear and stay bright for a few years due to radioactive decay of material producing them. So new types of optical transient, I think, are definitely on the list. I think new types of solar system object are going to come up in the Vera Rubin Observatory. We're going to find billions of asteroids. It's basically a near census of the solar system. And so we'll see things in orbits that we haven't seen before. And I'm interested in all sorts of interesting things like retrograde orbits and things going backwards. Many more of the interstellar objects that we've so far found two. So I'm hoping we might get 100 or so interstellar objects. That will be exciting. And then you can get very exotic. So I think my favourite sensible use case for looking for the unusual is that some theories of particle physics predict there should be things called cosmic strings, which are very massive particles that are sort of remnants of bizarre processes that happen early on in the universe. And they would show up in an image as a disconnect. They have a lensing effect. So you'd almost see the universe slip slightly as if it had gone down an earthquake fault. And so if we see that anywhere in the universe, then we'll have made an enormous discovery. So, of course, we're going to look for those as well.
You did mention Oumuamua. What do you think that was?
Well, I think it was a fragment of another solar system, which is why I'm excited by it. So I actually diverted a lot of my own work to work on interstellar objects because I thought Oumuamua was so interesting. It was unusual compared to asteroids and comets in our solar system, but not that unusual. It was sort of, if you found it, it would be a 1 in 100 type thing here. My collaborator and friend Michelle Bannister, who's the real expert on this stuff, and led some of the campaigns to follow up on Oumuamua. The thing she likes to remind people is that one of the most unusual things about Oumuamua is that anyone cared about it. The number of things a few 100 meters long in the solar system that we've pointed 8-meter telescopes at are really small because, that's just rubble. We'll worry about that later. So I think it was a fascinating object. And what we're finding is that we can predict like what types of interstellar objects you get depends a lot on all our understanding of the galaxy, how things move in it, where star formation happens, and how planet formation happens throughout the galaxy. So when we have more of these things, we'll be able to say something about the types of process that's got the galaxy. Now, you're asking, I imagine, because Avi Loeb at Harvard, of course, is a very strong advocate of the fact that he thinks that the Moon was an alien spaceship. I would love it to be an alien spaceship, but you need extraordinary evidence for that. And Avi, I'm afraid, hasn't read, as far as I can tell, the literature from people who study small bodies and who understand these things. There's very little evidence that it was anything other than a slightly unusual asteroid stroke comet.
No, sure. No, I've had Avi on the podcast, and unfortunately, the extraordinary claims require extraordinary evidence. I'm not smart enough to be able to question him on the details, so I'm very much. I like the idea that it was something, but I tend to agree with you.
Everyone does, right? And Avi is not wrong that looking for unusual things is good. I think there is a point though where you have to look at what we know about other small bodies. People who are interested, there are excellent commentaries from Steve Desch, Desch online, which I'd recommend that go over. Jason Wright was involved as well. They go through Avi's claims in detail and give you the astrophysics, the planetary science that does this. I mean, I've been in this position myself. When you find something unusual, when you find an unusual result, it's always fun to think about, could it be aliens? We've been down through it a few times. In fact, the original title for the book was "It's Never Aliens," because every time you have this thought. But we didn't use the title because one of the publishers said that we wish it was, which is fair. But so look, the idea that we should consider that it was an alien spacecraft is not wrong. But where Andy goes wrong is that he doesn't know enough about what we're comparing to, and so he comes up with the idea that it's 1 trillion to 1 chance that it could be natural, and that number's just not true.
No, sure. Well, look, for my non-UK audiences, they may not be aware that as well as being a professor of astrophysics at the University of Oxford, you're also a pretty, I would say, iconic presenter in the UK of the BBC's legendary Sky at Night programme, which has been going, I don't know how long it's been going for, decades, I think,
let's see, 1950. Well, we started not with me, I should say. The remarkable thing about the programme is that it started in April 1957, which is 6 months before Sputnik, and it was commissioned for three episodes, and has been going originally every new moon, and since the 90s, every calendar month, more or less, with a few gaps.
It's one of the only shows on the BBC that has stood the test of time, I think. What challenges and joys come with presenting astronomy to a broad audience, and how has the public's interest in space evolved over the years, or since you've been involved in Sky at Night?
Well, those are good questions. I learned a lot. I got to overlap with Patrick Moore, who was the presenter from 1957 right up until 2012, with a rotating cast for the last decade or so. And the thing about Patrick was that he understood that you could talk to two audiences at once. So every program he made, he was keen to talk to people who'd never ever thought about this stuff before, and to give the latest results. So a program about a Mars rover would include an opening which is, hello, Mars is the 4th planet from the sun. It's red. It's covered in deserts. You give that information. But then you can also say, and the most exciting thing about this planet is that it's discovered chlorate, an alkaline chemical in the soil. Now, what that means is that, I think it's very easy as a science communicator, as a writer, as a broadcaster, to decide that you're going to do one of those things or the other, to overpitch so that, people, I won't name presenters who do this, but it's very easy to entertain people while giving the impression that you know more than they do and miss out the introductory stuff. It's very easy to get fixated on the introductory stuff, to say that Mars is the 4th planet, and then suddenly you've done half an hour, but you've made the same program about Mars that you could have made 10 years earlier, and you haven't given this impression that stuff is changing. And I think that's the biggest change in the 20 years I've been doing it. I think the access to information that people have is now so much more. The fact that you can go online, and if you're there at the right time, you can literally be the first person on Earth to see a picture beamed down from Mars, just because if you happen to be on the page and click refresh, is amazing. The fact that people can be fans of these missions and of telescopes and of observatories in the same way that you can be a fan of a sports team and follow what's going on. I think that's really exciting. And so partly what our role on the Sky at Night has become is to be a bit of a guide to what else is out there, to other people, to other ideas and other missions that people can go and follow up on online.
That's fascinating. And so when's your book out? It's the 21st of March on hardback, right?
21st of March if you're anywhere except the US and Canada, then where it's called Accidental Universe, and then the American edition, in which we have changed very little. I've changed one cricket reference to a baseball reference, taken some U's out of words. So that's called Accidental Astronomy, and that's out in June.
Fantastic. Well, look, before you go, I just want to thank you so much for everything you do. You did mention something at the beginning that we have to go back to, and that's your podcast, Dogstars,
Yes.
because I can't believe you managed to link your dogs to the stars somehow. So it sounds quite unconventional, and I genuinely never heard of it, so I'm definitely going to subscribe to it. Where did that idea come from?
There's two things. The simple answer is that since lockdown, I'm a dog owner of Max, who's a recalcitrant lurcher. He's a rescue, and so I spend more time outside under the sky than I used to, and I found that really rejuvenating. And so all the podcast is it's 10 minutes of me telling a story about something in the sky, literally while dealing with whatever North Oxford throws at us. So Max is keen to find food, so there's a lot of shouting at the dog. I think the first episode includes "Don't pee on the car" randomly in the middle of a discussion about Mars. So people seem to enjoy that. But the slightly more serious answer is that I think, as I said, it's very easy to become somebody who stands on a stage and talks as if I know stuff that you don't. And I want to do the opposite in every time I try and communicate with everyone. And I think everyone can imagine being out on a walk with their dog.
Yeah.
So I think it's a really low-key, easy way to chat about the cosmos. And we hear from other people who've got out on their own walks and seen the same things or seen other things. So hopefully it's a way of connecting with maybe a different audience or people who want a little bit of astronomy in their lives rather than to be super fans and to follow Hubble around.
It's very fun. It's very kooky, and I think that's what makes us English. So thank you very much. Cheers, Chris.
Cheers. Nice talking to you.